Hey there friends, this is Moimes and welcome to my next tutorial on programmable blocks. In this episode we're gonna drop some bombs on disgusting smugglers. You may see them on the horizon. Unfortunately we don't have any GPS coordinates to direct our bombers, so let's see if we can get some coordinates for our bombers to drop their bombs on. Let's take control of our designator, and as you can see there's the smuggler spaceport, and this is where we are gonna drop our bombs. Unfortunately our strategic bombers are pretty weak defended, and the smuggler's port got some heavy defenses we want to avoid. So to do that we're gonna use this command vehicle. It's nothing really special, it features only an antenna, some programmable blocks, some screens. These screens are not used at the moment and we may use them in a future tutorial. And we're gonna use this Laser Designator to get some coordinates. As you can see, the Laser Designator is already tracking our target, and we're gonna raycast a laser on the smuggler's port and display them on this screen. So let's jump in our vehicle, press K, get remote access to our Laser Designator. Let's take a look at the camera. And as you can see, the target is in view. And now we activate the Laser Designator's program to send some GPS coordinates to our command vehicle. So let's press 7. Okay, if that worked, we should see some GPS coordinates on this screen. And as you can see, it worked. We got some GPS coordinates. We can now simply copy from the screen. Oh, I got thrown out of the vehicle. So, as you can see, we got XYZ coordinates. And yeah, let's copy them and make a new GPS coordinate for our bomber pilots. Let's create a new coordinate. Paste the X value. Press enter, just to be sure. Copy our Y coordinate. Paste it. Copy our Z coordinate. And paste it. Oops, not 2 times, only 1 time. Okay, something seems not quite right. Oh, we got 2 minus. Only 1 is needed. And if we done everything right, there should be a coordinate right on the smuggler's port. So let's take a look through the camera. And as you can see, we got a coordinate near the spaceport. It's not 100% exactly because I messed up the camera rotation, but with a few more tries we should get our laser target right on the smuggler's spaceport. But for our strategic bombers this should be enough to annihilate the whole spaceport. But as this is a tutorial, I'm not gonna simply drop some bombs on some disgusting smugglers. Before we're gonna do that, I'm gonna show you how the whole system works. Let's get out of the vehicle and take a look at the Laser Designator. The Laser Designator is pretty simple. We only got a camera, an antenna, a programmable block, and some screens, but they are not needed, and this button. Yeah, well, it's quite simple. The camera sends a ray to the location it points at, and from the hit of the ray, it gets a coordinate with XYZ. After that, we're gonna use this coordinate and send it to our command vehicle, and the command vehicle receives it and displays the coordinate on the screen. So it's a basic intergrid communication. The command vehicle itself is pretty similar to the Laser Designator. It has a programmable block to receive the message and a screen to display the message. In this case, these are 3 coordinates. And yeah, well, these screens are not needed yet, as I said before. And of course, we got an antenna to enable intergrid communication and some other stuff like these rotors just to make it look nice, and we can extend or retract our antenna. Yeah, well, this is just for the looks and really not needed. Okay, before we continue calling in our bomber, I want to show you how the scripts running this system work. There are 2 scripts, one for the designator and one for command vehicle, or one for a transmitter and one for a receiver. Okay, if you have watched my previous tutorial, you'll know that I don't like to use the native Space Engineer code editor, so let's switch to Sublime Text instead. It's my favorite code editor. And let's get started. Yeah, we start with the Laser Designator, and it gets some method like scan, get display panel, write ln or write line, clear screen, and transmit. Yeah, these methods do really that what they are named after. Like scan actually scans a point, get display panel gets the screen attached to our Laser Designator, write ln writes a line to our screen without deleting the previous text, and clear screen clears the screen. And the method transmit transmits data to our command vehicle, or better said, to every antenna in range. The other script I want to show you is the script attached to our command vehicle or our receiver. And as you can see, we got some similar methods like the write line, clear screen, and get display panel. These methods are exactly the same as on the Laser Designator, and I'm gonna explain them only once after I showed you all the methods. And yeah, well, we got some additional methods like receive GPS, which is used for receiving a message that contains some GPS coordinates, and the print GPS, which prints the formatted GPS coordinates to the screen right to our programmable block, so we can read the GPS coordinates at our command vehicle and create a GPS coordinate from them. But let's get back to our designator script, and I'm gonna explain each method line by line so you understand how they work. Yeah, well, let's start with the helper methods to write stuff to the screen, because I think this is pretty important, because you can't really use a GPS coordinate without writing them somewhere so you can read them. Yeah, let's get started. First is the get display panel method. It returns the implied text panel attached to our Laser Designator, so we can write to it. And as you can see, we're doing in this line nothing but retrieving the text panel. Pretty important about this method is you need to retrieve it as an implied text panel. Otherwise, you get a type error and the script doesn't know what to do with the object we're retrieving from this method. So we're gonna use it as implied text panel. After that, we're gonna simply return it, so other methods can use it. The next method on our list is the writeLn or writeLine. You can see we're gonna use it in our scan method to display the GPS coordinate on the screen. What we're doing first is getting the current text of our text panel so it won't get deleted. And we're gonna write our next line under it. This is done in this line. We get the display panel first and write a public text to it. And to do this, we're gonna use the current text, add the next text, which is a parameter of this method, so we can write any text we want to it. And after that, we're gonna add a line break to start a new line. The next method is clear screen. This is pretty simple. All we do is delete everything, or we're gonna write a public text which is empty. Okay, these were the basic methods we're gonna use on the designator and the receiver. So I'm not gonna explain them again for the receiver because they are pretty much the same. The only difference is the name of the text panel, and yeah, it's not pretty complicated and you can use them in any case on any ship you want without having to worry about some bugs or something. Yeah, these are some standard methods I use on nearly any script to display some data or text or whatever. Okay, next on our list is the scan method. This is a little bit complicated, but don't be afraid, it's not that hard to understand if you're gonna go through it line by line. Okay, first we want to do is get our camera. It's called laser camera in this case, but of course you can call it whatever you want. You can call it XDYF if you want to, but laser camera is a pretty good describing name in my opinion. And as you can see, like in our get display panel method, we're gonna use the grid terminal system, which is a static class, and use the method get block with name. And we're gonna get the block with the name laser camera as an iMyCamera block. The iMyCamera block interface or object type is used to represent a camera block. I think this is quite understandable. And yeah, what we're gonna do with our laser camera first is enable the raycast. So the camera can actually point a laser at a point. We set this value to true, so the camera can raycast at a point. Next one, we're gonna use an anonymous type. Anonymous types are called var or variable, and the program uses these types if we don't want to specify the type of a variable like this one at this point. It's quite handy, but be careful with using anonymous types. It gets pretty messy if you write big scripts, and it's always better to not using implicit types like var and instead use explicit types like iMyCamera block. But at this point we can use a var without getting our script too complicated. And yeah, well, we assign to our scan value the laser camera and raycast in a distance of 10,000 meters. We don't want to have any offset, so we get a straight line. And yeah, as you can see, this unit is in meters. So we get a point in range of 10 kilometers. Okay, next one is a try phrase. The try is used to actually try the stuff in this block, and if that fails, we're gonna catch it and just write scan failed to our screen. Okay, but let's assume our method will be successful, and first thing in our try block is we're gonna use the raycast from our laser camera to get the coordinates as a vector 3D. Vector 3D variables are, yeah, you can imagine them as XYZ coordinates. They got values that are called XYZ, but I'm gonna explain them in the next lines. And all we're gonna do is, in this part, is assign the hit position of our raycast to this variable called coords, or coordinates. Next thing we're going to do is define some strings called XYZ in non-capital letters and assign the XYZ values of our coordinates to them and convert them to a string so we can print them on our screen. Yeah, well, that was not complicated. Just access the XYZ values of our coordinates and assign them to different strings. Of course, we can use an array for it, but in this case, I think it's easier to use single variables for them, so it won't get messy and we don't have to think much about it. Yeah, and after that, we're gonna print some lines to our screen, like GPS as first. So we know on the screen are some GPS coordinates, and after that we're gonna write our X value, our Y value, our Z value. As you can see, we're just using a string first and add our X coordinate to them, and our Y coordinate and our Z coordinate, and yeah, well, that's it. Okay, next method is the transmit method we're calling. So this method I'm gonna explain next. This is not really complicated again. So we get our antenna. In this case it's called area surveillance system. And yeah, we do basically the same as in this method or in this method. And after that we're gonna call the transmit message method of our antenna. And this method accepts two parameters. First, a message or a string. We're gonna specify in this parameter, so we can pass our message to this method and transmit it as a message to other allied antennas. You can specify which faction the message is gonna broadcast it to. In this case, we're gonna use the Aleph faction. Of course, we can use everyone or enemy or whatever. There's some documentation that I'll link in the description. And yeah, well, that's it. It's not really hard. Get the antenna, transmit the message. Okay, let's get back to our scan method. Okay, as I said, after we scanned, we're gonna transmit it. Our message will be GPS first, so we are gonna transmit a GPS tag, and after that we're gonna transmit the X, the Y, and the Z method separated by commas. This is really important because we want to use the message as a CSV value or a comma separated value, so we can easily parse it to any format we want later. Okay, that's it for our designator script. So let's switch to our receiver script or our command vehicle script, whatever you want to call it. And yeah, well, as you can see, we got the same display methods like in the designator script. So I'm not going to explain them again, just scroll back to the point where I'm explaining them in the designator script. And instead I'm going to explain the receive GPS and print GPS method. Let's start with the receive GPS. The receive GPS method returns an array of type string, which means this is only a group of strings. And yeah, it accepts a parameter called MSG or message, and it's of type string. So we are gonna pass some text to our receive GPS method and do something with it. Okay, first line is we're gonna define a new array of type string called coordinate message, which is what we defined as a parameter or what we passed as a parameter to this method. And this string is splitted by this character. So we're gonna separate the GPS tag from our actual coordinates, and we're not gonna use the GPS tag in our next line, and instead the comma separated value we send from our designator to our command vehicle. Pretty important is, if we are going to use the split method, we need to convert the string to a char array with this method. I don't know why this is needed in C#, but it's mandatory and you have to do it. And just remember, if you're gonna use the split method, you need to convert the string in this method to a char array. But yeah, well, this is just mandatory and try to remember it. Otherwise, it will throw an error. Okay, in the next line, we define another string array. In this case, it's called coordinate array. And this array is the first entry in our coordinate message. Pretty important. Remember, arrays start counting at 0. So this is actually the second value in our coordinate message array. And we're gonna use this value and split it again. As you might remember, we passed in our designator script the GPS tag first, which is separated because of this one line before our actual line. And after that we got X, Y, Z values separated by commas. And yeah, well, this is what we're gonna do here. We take the X, Y, Z values, which are at position 1 in our coordinate message array, and split them again by commas. And again, convert this to a char array. And after that, we got a new array with the X, Y, Z values at the positions 0, 1, and 2. Like this one. Okay, as you can see, X is at position 0, Y is at position 1, and Z is at position 2 in our array. But let's delete this again, so we don't mess up our script. And well, after that is done, we're gonna return our coordinate array. Yeah, well, now we got all the coordinates in an array at our receiver or our command vehicle. And after that, all we need to do is to print them to the screen so we can read them from there and create a new GPS coordinate in our Space Engineers interface. Okay, this is done in our print GPS method. This one has no return type, as it doesn't return any value and only writes stuff to the screen. And it accepts the string array we return from our receive GPS method as parameter, and we're going to use that in this method. As you can see, we got another string array. These are values just to add them before the coordinates, so we know which coordinate on the screen is which value. And after that, we're gonna iterate through our CSV string array we defined in the parameter. As you can see, we're using the length of our CSV array as the condition which has to be false to break this method. Yeah, but don't be afraid, just remember n has to be smaller than the length of our CSV array, and yeah, just copy it, and remember you have to write a for loop like that for each entry in our array. Yeah, but let's get into the for loop itself. Okay, for each CSV value, or for each value in our string array, we're gonna write a line to our screen, which starts with this bigger S operator, just for cosmetic reasons. You can ignore it if you want, but it looks better on the screen. And yeah, that's why this is here. And in all our other methods you might have seen. Yeah, but we're gonna write, as I said, this one at the coordinate ID, yeah, which is x, y, and z. So in the first run of our loop, we're gonna write this symbol at an x, which is the zeroth entry in our array. And after that, we're gonna use this symbol just to separate it and make it easier to read. And after that, we're gonna add the actual coordinate, which is the nth entry in our parameter, and print this whole thing to our screen. And we're gonna do this for each entry in our CSV array. Yeah, well, that's it. So these were the methods we're gonna use in our script. And now we just need to call them in our main method. Okay, but before I'm gonna start explaining the main method, I want to talk about how the transmitting system in Space Engineer actually works. Well, basically, the antenna of our area surveillance system, or our laser designator, broadcasts the message we defined in our transmit method to all antennas in range. And that's why the antenna has such a limited range of 200 meters, so we don't affect any other antennas in a wider range, and only transmit the coordinate to our command vehicle. And let's take a look at the laser designator. As you can see, the antenna has a pretty small broadcast radius. And as you can see, you can assign programmable blocks to antennas. In case of the laser designator, we're not going to do that, because the designator script is run by the remote control and not by an incoming message. And instead, we use the antenna of our command vehicle. Let's extend it again, just for cosmetic reason and because it looks cooler. And let's take a look at the terminal of our command vehicle. Okay, here you see we assigned the programmable block to our antenna of the command vehicle, and that means if a message is transmitted to this antenna, the programmable block is executed. Or better said, the main method of our programmable block is executed. So, pretty important is that we filter incoming messages. So we don't run all these methods every time any message is transmitted, because maybe an enemy will inject a dangerous script to our command vehicle, and we don't want that. We don't want any hackers to mess with our command vehicle. And if you take a look at this method, you see they will only run if the message contains a GPS tag. But let's switch back to Sublime Text and take a look at the methods, at the main methods. As you can see, I added in the meantime an if statement, so we can add some other scan modes later maybe. You can of course delete this if statement if you don't want to add any other scan modes or whatever to the laser designator. And yeah, well, basically this is run every time. we execute our designator script, and what it does, it clears the screen, scans, and as I said before, we're gonna transmit the result of our scan to our command vehicle. Okay, if the command vehicle receives a message with the GPS tag, we're gonna clear the screen, write the whole message to the screen just for debug reasons, so we see if our receive and print GPS method work correctly. Of course, you can delete this line if you don't want to debug the script anymore. I just put it there for clarity, so we know, okay, if everything is set up correctly, we should see the coordinates of our GPS point on the screen. After that, we're gonna define a new string array. It's called coordinates in this case. And yeah, well, basically split up the message with our receive GPS method to separated values in our string array. And after that, we're gonna print everything to the screen with a new line for each X, Y, and Z value. Okay, that's it. That were the scripts for the designator and the receiver. And let's switch back to Space Engineers. Okay, now that we are back in Space Engineers, let's get to our radio and call in the airstrike. HQ, this is Minus, requesting airstrike at minus 5699.7.72, minus 5601.22, minus 17783.36.
Coordinates received, airstrike is inbound.